The name of this lesson is Applications of 45, 45, 90 and 30, 60, 90 triangles. You want to be able to choose the appropriate special right triangle rule and apply it in situations when we have an unknown. And so these are going to be word problems, okay? So the first one says, Mr. Ryan is flying his single engine plane at an altitude of 2,400 feet. Altitude is always going to be at a 90-degree angle. So here's our altitude, 2,400 feet. He sees a cornfield at an angle of depression of 30 degrees. This is going to be an important term when you see angle of depression. An angle of depression comes from the horizon looking down. It's going to be outside of your triangle. He's going on the horizon here, so at a parallel to the ground. And when he's looking, the angle of depression is going to be this angle out here, outside of the triangle. So inside your triangle, this is a 90-degree angle, so 90 minus 30 is 60. Okay, so now you know we have a 30, 60, 90 triangle, and so you need to go back and know your rule, and our rule says across from 30 is x, across from 90 is 2x, and across from 60 is x to the square root of 3. So the question they ask is, what is Mr. Ryan's exact horizontal distance from the cornfield? So horizontally is going to be this distance right here. So x times the square root of 3, and x is 2,400 feet. So your answer is 2,400 times the square root of 3 feet. Okay, let's look at the next example. Okay, this one says quick check, so if you would take a moment and just pause the video and see if you can read it and see how you would set it up. Okay, I hope you pause for a moment. Digna is making a ramp to try out her car for a Pinewood Derby. The ramp support forms a right angle. So here's the support, okay? This is the support, and this is the ramp. The ramp is this right here. So the support has a 90-degree angle, so here's our 90-degree angle. The ramp also forms an angle of 30 degrees with the base. So this is the base, so here is going to be our 30-degree angle, so this would make this our 60-degree angle. Then we want to label across from 30x, across from 92x, and across from 60, x to the square root of 3. Now, let's look. If the base is 12 feet long, so the base is 12 feet long, so this is the base, okay? And how long is the ramp itself? And, okay, the base is 12 feet long. How long is the ramp itself? I'm missing the... Oh, the ramp is 12 feet long. I'm sorry. The base is 12 feet long. So here's the base, and that's 12 feet. Okay, so how long is the ramp and how tall is the ramp? So how long is the ramp? This is the ramp itself, so that's going to be 2x. And then how tall is the ramp is right here. That's going to be x. So the first thing we need to do is we need to solve for x. X divided by, x times the square root of 3 is 12. Divide by the square root of 3. And we get x is 12 divided by the square root of 3. So we're going to multiply the square root of 3 over the square root of 3. 12 square root of 3 over 3. 12 is divisible by 3, so we can simplify that to 4 square root of 3. So we just found x is 4 square root of 3, and this is x right here, the height of the ramp. So this is 4 times the square root of 3. Now the next thing they ask about is 2x. How long is the ramp itself? So if you multiply 2 times 4 square roots of 3, you get 8 square roots of 3. And these are feet. So it's 8 square root of 3 feet is the length, 4 square root of 3 feet is the height. Okay, let's look at the next one. A patient is being treated with radiotherapy for a tumor that is behind a vital organ. In order to prevent damage to the organ, the radiologist must angle the rays to the tumor. If the tumor is 7 centimeters below the skin and the rays enter the body 7 centimeters to the right of the tumor, find the distance the rays must travel. This is actually like a real-life situation. If you're getting radiation treatment, they are going to avoid any vital organs, and so they are going to be looking to see how they can enter the rays. I can't really draw this very well, but let's just say, I'm not going to be able to draw it, but here's the tumor, and it is 7 centimeters below the skin, but they need to come at it from 7 centimeters over here. So I tried to make those look the same length. Let's make our tumor a little bigger. And then, so this, the distance they want to know is this distance right here. So anytime that you have a right triangle and it's isosceles, so the two legs are the same, it is a 45, 45, 90 triangle, okay? Across from 45s are x, and this is x to the square root of 2. So if x is 7, x to the square root of 2 is 7 to the square root of 2, and this is 7 to the square root of 2 centimeters. That is how far the rays must travel. Okay, let's look at the next example. There we go. Okay, so the length of the altitude of an equilateral triangle is the square root of 3 over 2 feet. Okay, so we have an equilateral triangle. So that means it is a triangle where all the sides are the same length and all the angles are the same. We know that all the angles are 60 in an equilateral triangle. When we draw the height in an equilateral triangle, or the altitude, it bisects the angle at the top and creates a 30, 60, 90 triangle. It also bisects the length of the base there. So, but we also can write our pattern, x, 2x, and x to the square root of 3. Now here they're telling us that the altitude is the square root of 3 over 2. So that is this. So this one gets a little tricky in the algebra, okay? But we have x to the square root of 3 is equal to the square root of 3 over 2. So there's a couple different ways to go about solving this problem. And so one thing to do is to divide both sides by the square root of 3. We want to get the square root of 3 by itself, so we could do that. We could divide this by the square root of 3 and we would get x. And we need to divide this side by the square root of 3. If you remember, division, well, we can, okay, this is a square root of 3. We can write that as a single number over 1, okay? The square root of 3 and the square root of 3 over 1 is the same number. And so what we do when we're dividing fractions is we multiply by the reciprocal. So I can take the square root of 3 over 2 and multiply it by 1 over the square root of 3, and I get the square root of 3 over 2 square roots of 3. This is going to cancel out, and I'm left with 1/2. Okay, let me solve the same problem another way, because I know that one's a little bit tricky. Let's look at it like this. Let me erase that. Okay, so again, we know that x to the square root of 3 is equal to the square root of 3 over 2. We can write this as a proportion. We can write this over 1, and we know a proportion are two ratios that are equal, and we can cross multiply, and then we get 2 times x to the square root of 3. I'm going to write that as 2 square root of 3x because I just want to keep my x by itself, is equal to the square root of 3. And so I divide by 2 square roots of 3 and divide by 2 square roots of 3. And again, this is x is equal to, and that's going to cancel out, and x is equal to 1/2. A couple other ways to solve it, but you're going to have to be comfortable with working with fractions and radicals. Okay? The quick check's a little easier, so please pause the video and try and do the quick check. hope you paused it. Equilateral triangle, each side is 11. Okay, and we want to find the altitude. So here's going to be the altitude, and that's going to be my 30, 60, 90 triangle. So we can again put our x, 2x, and x to the square root of 3. So if 2x is 11, divide by 2, and x is, you can call it 5.5 if you want. And then the altitude is x times the square root of 3, so 5.5 to the square root of 3. Some people might have written it as x to the square root of 3 over 2. That's the same thing, and that's fine. Okay, let's look at example 4. Sorry. The diagonal of a square is 8. Find one side. Okay, in a square, all the angles are 90. When we draw the diagonal, it creates 45, 45, 90 triangle with x, x, and x to the square root of 2. And they tell me that the diagonal is equal to 8. So x to the square root of 2 is equal to 8. Divide both sides by the square root of 2. 8 divided by the square root of 2, and then we have to rationalize the denominator. Multiply by the square root of 2 over the square root of 2. 8 square root of 2 over 2. We can simplify that one step further because 8 divided by 2 is 4. We get 4 divided by the square root of 2. If you're a little confused by simplifying the radicals or the rules for special right triangles, watch one of the previous videos because we go over all that in those, okay? We're just trying to do the word problems now. So again, if you're having trouble, go back to a previous video. But let's look at this quick check. It's the last problem. Okay, the length of the diagonal of a square is 10 to the square root of 2.